The entire universe is made of two things, matter and energy. Is energy exciting? Absolutely, because there are so many different forms of energy all around us. In this video, I'll be talking about the different forms of energy, and then we'll do the top 3 exam-oriented questions on this topic. You might have heard of these different forms of energy, such as potential energy, kinetic energy, heat energy, chemical energy, light energy, sound energy, electrical energy. I mean, the list is endless. But we'll be discussing some of these important energy forms in detail in this video. What is potential energy? Let's take a look with a couple of examples. If I lift this hammer to a height, it has energy stored in it. That's called potential energy. Because if I release this hammer, it can do work on the nail. So it has this potential energy due to its position. Let's take a look at another example. So if I compress this spring with this block, and now if I release it, the spring is able to do work on the block. How can it do work? Because of its compressed configuration. So it has potential energy due to its compressed configuration. Potential energy is energy due to a height or due to its configuration. Let's put potential energy on our concept board. Potential energy is due to position or configuration. Next, we have kinetic energy. So what is the difference between a stationary ball and a moving ball? So the object is the same. The difference is a moving ball possesses kinetic energy. Kinetic energy is the energy in motion. So when you're running or you're walking, you have kinetic energy. A moving car has kinetic energy. So what do you think about a flying bird? So since it's flying, it has kinetic energy, but the bird is also at a height. So it's got potential energy as well. And this sum of kinetic and potential energy is known as mechanical energy. Let's stick kinetic energy onto our concept board. Kinetic energy is for motion. What is the difference between a glass of cold water and a glass of hot water? Ouch! The glass of hot water has more heat energy than the glass of cold water. Similarly, when you burn something like wood or a fuel like petrol or diesel, it gives out heat energy. Heat energy is usually measured in calories. So do you know how do we define 1 calorie of heat energy? It is the amount of heat energy that you need to add to 1 gram of water to increase its temperature by 1 degree centigrade. And 1 calorie is 4.2 joules, where joule is the SI unit of energy. Now let's place heat energy on our concept board. Heat energy is associated with how hot an object is. Chemical energy is the energy stored in a substance that is released through a chemical reaction. Now, what are some examples of chemical energy? Fuels are good examples. Fuels like coal, petrol, diesel. And we know that burning is a chemical reaction. So when these fuels burn, they release out energy in the form of heat and light energy. The food that you eat gives you energy. So what form of energy is food? The food is like a fuel to our bodies. So it is also considered as chemical energy. I know it doesn't sound good, but in the end, we are eating chemicals. The energy of food is measured in calories. Earlier in this video, we saw that heat energy is also measured in calories. But be careful, this is a common confusion because the calories of heat and calories of food are not the same. The heat calorie we wrote with a small c, but if you noticed, when we are talking about food calories, we are using a capital C. The heat calorie is a very small amount of energy. The energy needed to raise 1 gram of water by 1 degree centigrade. But food calories is much bigger than this. In fact, 1 food calorie is 1000 calories. And so it's often written as kilocalories or kcal for short. Let me go ahead and show you. So do you know how much energy you get when you drink this pack of juice? So you can find that out by looking at the product information here. So as you can see, this 200 ml juice contains 50 kcal of energy. So that's 50 kilocalories of energy in this pack of juice. Now, do you know how much calories are there in a banana? It's about 100 calories of chemical energy. A cup of milk contains about 150 calories of energy. And a bowl of rice is 200 calories. Do you know how much an average teenager needs per day? It's about 2000 calories of energy per day. And remember, when I say calories, I'm talking about food calories, so it'll be 2000 kilocalories of energy per day. Now let's pin chemical energy on our concept board. Chemical energy is linked to fuel or food. Light energy. What are sources of light energy? The sun, bulbs, LED lights, candles, these all give out light energy. Light energy helps us to see the world around us. If there was no light, then our discussion would look something like this. Now we don't want that, right? Lights on. Let's stick light energy to our concept board. Light energy helps us see. What is the energy that helps you hear this video? That's right, it's sound energy. So when we are speaking, we are producing sound energy. A music system produces sound energy. If you touch the speakers, you can easily feel the vibrations, especially if the music is a bit loud. Similarly, while speaking, if you put your hand here on your neck, you can easily feel the vibrations. Sound energy is produced by vibrations. Now, if there was no sound energy, then our discussion would sound something like this. We don't want that, right? So let's get the sound energy back and let's move on with our discussion. Let's put sound energy onto our concept board. Sound energy enables us to hear. Today, our daily lives are highly dependent on electrical energy. If you look around you, you can see that the lights, fans, TVs, refrigerator, computer, everything is running on electrical energy. So how do we get this electrical energy? It's coming from the power station to our homes through these long electric cables. And when you get the electric bill at the end of the month, do you know what are you paying for? You're paying for the amount of electrical energy that you consume that month. So if you want to reduce your electricity bill, do remember to turn off your lights and fans when you're not using them, and then you'll save on your bill. Let's put electrical energy onto our concept board. Electrical energy can be obtained from the plugs in our house or by using a battery. So here is a summary of all the energy forms that we have looked at in this video. I would encourage you to pause here and note down this summary. Now that we have looked at all these different forms of energy, let's move on to our top 3 questions on this topic. Question 1. I'm going to do some things here and you need to be a science detective and identify all the forms of energy that you see here. As a recap, let's look at all the forms of energy that we have learned in this video. Okay, detective, are you ready to identify the different forms of energy? Here it goes. I'll play it one more time for you. Here it goes. So how many different forms of energy did you get? Let's analyze the video. I'm switching on this lamp. What form of energy is supplied to the lamp? It's electrical energy, supplied through the wire here. When the lamp is on, what form of energy is the bulb giving out? Light and heat energy. When I lift this ball to a height, the ball has potential energy. As it falls down, it gains speed. So the ball has kinetic energy. When it bounces back to a height, the ball has potential energy. When the ball is somewhere in the middle, as shown here, it has both height and speed. So the ball has both potential and kinetic energy. And this sum of potential and kinetic energy is called mechanical energy. Do you hear the ball bouncing? So that's sound energy. I am drinking this juice. Juice or food is chemical energy. So all these forms of energy are present in these simple things that we use in our everyday lives. So all the forms of energy that we have learnt are present in this question. Question 2. What is the energy of a flying aeroplane? Hint: it can be more than one form of energy. So to help you choose, let's go ahead and pull up our concept board. The answer for a flying aeroplane is potential energy and kinetic energy. An aeroplane is at a height, so it has potential energy. Since it is flying, it is in motion, so it also has kinetic energy. We can also say that the aeroplane has mechanical energy, since mechanical energy is the sum of potential and kinetic energy. Question 3. What form of energy is stored in a cell or a battery? I'm sure all of you have used a cell or a battery in toys or torches. What happens when the battery becomes really old and you don't replace it? It can leak. The chemicals inside the battery, they start leaking out. Since the battery is made of chemicals, the energy is stored in the form of chemical energy. When the battery is being used, a chemical reaction is taking place inside the battery and it supplies electrical energy. In summary, the battery stores chemical energy and supplies electrical energy. So next time when you look around you, I would encourage you to put on your thinking glasses and look for the different forms of energy around you. I'm sure you'll be able to identify them because energy is present everywhere. It's just in all these interesting different forms. And do remember to like, comment and share this video and also subscribe to my channel. Now I'm feeling tired. I need to grab some food. Some chemical energy. So off I go. Thanks for watching.